Someone has asked me that what would be the value of the investment if they start investing, let's say, a specific amount of money which is going to be consistent or constant for the rest of the period. Let's say 10,000 for the next 120 months at the rate of 10%. Remember, this 10,000 is going to be invested each and every month. That means that if this person is going to maybe deposit 10,000 into the investment account this month, another 10,000 is going to be invested the following month up to the end of the 120 months. Now the question is, what will be the value of the investment at the end of the 120 months? Now this brings us to what we refer to as the future value of an annuity. Yes, it is like an annuity, but we are getting the future value of this particular annuity because remember the 10,000 that you have placed today is going to start earning interest the same month. So by the end of the 120 months, it will have earned an interest of 10% for the next 120 months. Remember, this 10% is an interest rate calculated per annum. Then we have the number of periods, 120 months, periodic payments. We have this one. Now, every amount of money that is going to be invested each and every month is going to start earning interest now depending on the number of periods that are remaining. Now, to get the future value of an annuity, we have a very, very simple formula on Excel that is going to enable us to do this. And this formula is what we call the FV. Type equal sign. Once you have your parameters like this, type equal sign into any Excel cell, then just type FV. Yes, it is FV, and you can see it returns the future value of an investment based on periodic constant payments and a constant interest rate. Yes, guys, the interest rate has to remain constant for the rest of the investment period. Then we also need to have periodic investments, like we have 10,000, and it is also going to remain constant for the rest of the investment life. And we also need to have the number of periods, which is also going to remain constant. Now, once we do this, we are just going to click on that. Then we have a number of parameters that are going into this particular function. The first one is the interest rate. The interest rate in this case, we have 10%. We are not going to type 10%. We are just typing into that cell so that whenever we are going to change that rate, maybe from 10% to 12% or to 5%, the future value of our investment is also going to change. Now we type comma. The next one is the number of periods. Yes, this is the NPER, the number of periods. And the number of periods, you can see we already have it here, 120. We again type into that cell that contains that particular parameter. Then the last value here, we have the payment per term. Yes, payment amount per term. With the periodic payments, it has to remain constant. Again, we type into that, we click into that, then we just close. That is our formula, that is our function. It is a future value of an annuity, and it contains three compulsory arguments. The first argument is the interest rate, which is this one. The second argument is the number of periods, which is this one. And the last argument is the periodic payments, which is this one. Then after that, you just click on enter. You can see we have gotten a very weird value, but we are going to explain. First, this value is very weird because it is showing that it is negative. Actually, it is negative. It is showing there is some losses. Second, the value is very, very big. Now, the first reason why the value is very, very large in such a way that is not realistic is because we have not divided the 10% annual interest rate by 12 for us to get the monthly interest rate. Now we are going to come here at where we have the interest, then we are going to divide that value by 12. Then we are there. We now have a value that is not unrealistic, but it is still negative. But this value is negative because whenever we talk about, let us come here. Whenever we talk about the value like PMT, which is the payment per term, it calculates the payment for a loan based on constant payment and a constant interest rate. This particular function always assume that the value that is going to be produced or the output that we expect is going to be negative. So when that negative has been fed into this particular function, the whole result is going to be negative. Now for us to remove that negative part, we are just going to multiply the whole function by -1. So we do -1 times that, and you can see we have our value. Very, very easy, very, very clean. If we change this interest rate now to, let's say, 12%, our value here is supposed to change. You can see it has changed. If we change it maybe to 30% per annum, our value is going to increase. If we change it to 6%, our value is going to decrease. If we change it to, let's say, 1%, again, our value is going to decrease even further. Let's maintain it at 10%. If we change the payment per period or the number of periods to, let's say, 24 months, again, our value is going to decrease. If we increase this amount now to 50,000, our value is going to increase, but again, let's increase the number of periods to 120. You can see it has increased. Let's increase the interest rate to 12%. It has increased again. Now this is exactly how you can do it. And if you want to know exactly how much you are going to get after a particular period of time of constant periodic investment, then this is the formula that you are supposed to use. It is the FV, then you feed in the arguments that are inside there.